So we're going to take a look at the 5.6 homework, parametric motion horizontally and vertically. Again, there's some little details that I've been pointing out in class that you can expect to see on next week's test that aren't necessarily showing up quite as much in the homework. So let's go ahead, let's take a look at our problem. So the first one, part A, they want us to give the velocity vector. So I simply took the derivative of t squared negative 5t and the derivative of negative 4t squared. And then of course the derivative of 1 is 0. Part B wants the acceleration. So my derivative of 2t is 2. The derivative of negative 5 is 0. My derivative of negative 8t is negative 8. Speed, keep an eye on speed. This is a formula that you just kind of have to have memorized. Remember, these absolute value bars just mean total distance from the origin in this case, kind of like the absolute value bars that we're used to seeing means distance from the origin. So I've got to go ahead and plug 2 into my velocity vector and then start simplifying. Now, if you have your calculator, you can give the decimal equivalent, but without your calculator, we would just leave it as root 257. 2 is asking some of the same questions. So I've got my velocity vector in part A, my derivative of t cubed, my derivative of negative 6t squared, my derivative of negative 63t, and then of course the derivative of 4 would be 0. And then for the second part, my derivative of 4t is 4. For my acceleration vector, my derivative of 3t squared is 6t, my derivative of negative 12t is negative 12, my derivative of negative 63 is 0, and my derivative of 4 is 0. Like the last one, I've got to go back to my velocity vector so that I can take a look at my absolute value, or what is called speed. Remember, this is called speed. And I substitute in and simplify. Something you can expect typically is I wouldn't ask you to square 75 without a calculator. Some more of the same, just with a little bit of extra work needing to be done because of that square root. So I've got my derivative of 3t squared, 6 root t. Remember, I could rewrite this as 6 times t to the 1/2, which means its derivative would be 1/2 times 6, t to the negative 1/2. That's how I got my 3 in the numerator and my root t in the denominator. Derivative of t to the 4th, derivative of negative 5t squared, and then of course the derivative of constants is 0. So I've got to take now, if I want to get the derivative for 3 over root t, I rewrite it as 3 times t to the negative 1/2, and that means that I'll have 3 times negative 1/2, or negative 3/2, and then t to the negative 3/2. And so that's how I get this value of negative 3 over 2 square root of t cubed. And then, of course, my derivative for 4t cubed, that should say 12t squared, and then negative 10t gets me negative 10. And just like the last ones, when asked for speed, I go back to my velocity function. All right, so number 8 asks an important question and wants to know when this particle is stopped. If the particle is stopped, it means both of my parametric equations, the parametric equation horizontally, in other words, 3t squared minus 12t, and my vertical parametric equation, 2t minus 8, have to equal 0 at the exact same time. So I set each piece equal to 0. In the horizontal function, I can factor, and I get 2 times that my value is stopped. For the vertical parametric equation, I get 1 time, and the only time they overlap is when t equals 4, so that is when this thing is stopped. Multiple choice number 1 wants acceleration when time equals 3. So they've given us our velocity functions. So all I need to do is take the derivative once, plug in 3, and come up with choice B. Multiple choice number 2, they want the absolute value of v of 3. In other words, they want me to plug 3 into my velocity functions, square them, and take the square root, and that results in choice D. Again, you're going to want to keep an eye on ideas like when things speed up, when things slow down, when things are moving, let's say, right and down, or left and, let's say, up. And a lot of those questions aren't asked in the homework, so make sure you're checking your notes, and we'll definitely talk about it as we prepare for the test next week.